afterwards.
Teach me how to edit using
No,
the phone.
teach you how to go on airplane mode with
Oh, just up or down? Swipe down?
Yeah, we
From the
saw
top?
that.
From the corner or from the top right? Top right? Yeah, I get it.
Yeah, and so it was like an
Three pages.
I was like, no, like that's a player. And I was like, no, that's the coach. I was like, wait, that's not freaking out that coach.
Okay, we ready? Wait, read something. Do I have anything to give you or do I? You emailed yours in, right? I did. Okay. Who else walked in? Anyone else walk in? Anybody expect anything? Did you guys find yours? Someone's missing. Is she here? Is she coming?
Yeah.
Let me have her assignment.
Oh, yeah, she's coming.
She's coming?
Jordan Lee.
Okay.
She's like, I would join the team.
All right, let's get started. Where are we at? We're on week 12, the end of week 12, which means we're right up here. Next week's Thanksgiving break, so that means you guys are, for as far as this class is concerned, in 1 hour, you're gonna be on Thanksgiving break. And then we come back 1 week, we're doing SPC, quality control, upper and lower control limits, confidence interval. We'll have a lecture on December 5th, but then on December 7th, at 11 o'clock, right, like right now, but on December 7th, we'll start the final exam, but I have a great idea. Nothing that was lectured on December 5th will be on that first part of the exam. Only anything from November 30th back could be on that first part of the exam, but nothing from December 5th. So whatever I'm lecturing on December 5th could be on December 12th part of the exam. As far as, I haven't written the exam yet, especially not in 2 parts like this ever, really. But my thoughts are probably around a 40-minute time limit or 30-minute or something like that on December 7th for that little part. And then this on December 12th, it'll probably be like a whole hour's worth. It'll be about a little less than twice the size of a regular quiz kind of thing. So that's the thought. And I thought that would help out, especially for the night class, because their December 5th lecture is right before then they would take the exam, so it's kind of not fair for them to be examined on something they just got lectured on. So that's why I'm saying I want to do the same for both classes. That means whatever I lecture on December 5th will not be on that first part of the exam on the 7th. Okay, so we're on the same page there. Next announcement, right here. Last day to hand in late items. Go on Canvas, start looking at all your scores, and if you have anything, any zeros whatsoever, that's crazy at this point in time. The last lecture's on December 5th. That's the last time you can hand in late assignments. Don't forget, it has to be handwritten. Send me a picture, whatever you want. I'll still accept something after the 5th, but then it's an extra 50% off. So it'd be the late reduction plus an extra 50% if you're gonna hand it in after the 5th. So if you think there's anything, matter of fact, if you go back and you found missing items that you never handed back in, you can still hand in those missing items. You just can't hand in errors, missing items. You can still get 40% of whatever the points you lost if it's something that's really old. So there's that announcement. I'll remind you of that when we get back from Thanksgiving also. So let's see, where are we going here? I handed back all the homework, and you may have noticed it was a non-detailed grading. So that means if you got the word okay on top, that's 100. Do not take pictures of your answers and use it during the final, because I did not check and see if they're right. Seriously, it'd be in your best interest to use the answers posted than your own answers on a non-detailed grading, because I didn't go through the detail. This homework was so long, there were so many problems, that if I did a detailed grading, this would be the first one I wouldn't be able to hand back, because I wouldn't have it graded in time. It's just taking too long. Just doing a non-detailed grade, making sure you had all the work there for each one of the problems. You'll see where I took the pen with little big half circles along the left side. It's me searching every part. The first part, I wanted to see you had the setup and you showed some work to get Z. Then I circled that you did a norm S distribution equation with its result. Then I put a mark that you did part B, which is a norm distribution equation with its result. And I did that for each part. And then 7 and 8, there was 2 of each of them. So that's how that was looked at. If you have a missing item, if you have at the top, okay, but missing items, you can hand in the missing items, add them in at the end of class, and still get some of those points back if you want them. Okay, so let's see. Let's go back. Let's look at the new homework. Here we go, week 12 instructions. When's the homework due? On the 28th, the Tuesday that we get back from Thanksgiving break. What do the problems look like? 1A and B, 2A and B, 3A and B, 4A and B, 5A and B. Instead of 8, there's only 5. This homework is just like the homework you did for week 11, except it's proportion. And again, the difference is sample error of the proportion. This denominator is not like you did on the homework you handed in last week, or on Tuesday. This homework you're handing in when you get back is a different denominator to get Z. This equals Z, then everything's the same from there. Put your Z in and do your norm S distributions, all part of A. Norm dot distribution is all part of B's. These are all your B's, these 2 are your A's for your homework. There's only 5, so that makes 10 problems, 5 A's and 5 B's. Okay, so I didn't see you walk in. Put this right here for on the way out, please, tell them. Thank you. I want to point out, let's point out number 2, just so you know what you're looking at here. Number 2, according to a new research, 35% of US residents almost always online. What's the probability of proportion of 38% or less are always online from a sample of 70? There's your 3 numbers. Those are the 3 numbers you plug in here. Get your Z, plug your Z into here, then do B. B, the proportion being asked about, which in this case happens to be, what, 38%? The expected proportion, 35%. The standard error, which is right there, using that expected proportion. And then a 1 on the end. This is almost too easy. You want to just go home? Yeah? What do you mean? Don't you guys have class after this, another class?
No.
Seriously, this is it? Wow, thanks for showing up. I'm going to try to make it a good lecture, though. I have some good information today. Just got to get to it. Any questions of what's expected on the homework? You know what's due when you get back? How many of you will wait till after Thanksgiving to do this homework? If the camera could see all the hands. At least you're honest. All right. All right, so now, let's go to this PowerPoint. Don't forget, there's 2 Chapter 7 PowerPoints. There's Chapter 7 and there's Chapter 7B. This is from the B. I kind of want to put it all together. Kind of everything we've learned up to this point. I want to kind of put it in together so you can see how this is really used in the real world. So I thought we would talk about this story right here. By the way, did anybody notice that I posted last semester's first half lecture because the camera didn't work? Remember the camera didn't work, so I posted last semester's? Hope that worked. I don't know. Probably no one watched it because you said no one will see it until after Thursday, right?
Yeah.
So I could just wait till tonight? Okay, well, then nobody can tell me if it's any good or not, and if I need to re-record tonight or not. Anyway, so here's how it's used. Any marketing majors? 1, 2, 3. This example is specifically used by a marketing department. In the marketing department at Starbucks, you know, try to picture yourself as the manager you woke up in the middle of the night with this unbelievable marketing campaign, and you thought, oh my God, I'm going to get a promotion, I'm going to get a raise. This marketing campaign is so great in your mind that you were losing sleep. You had to write it down in the middle of the night. So now, here's the deal. When a big company that has, you know, Starbucks are all over the world. I mean, they're not just in the United States. There's so many of them. That it would cost millions of dollars to do this marketing campaign you came up with. So it's very typical for huge companies to say, look, let's first do some market research before we spend this multi-million dollars on this campaign to make sure it truly will work. This is how it's used in real business. In order for you as a manager to prove that it worked, you got to get some numbers. So in this example, it doesn't say what city it happened in, but let's just imagine this is Detroit. And you as the marketing manager, whoever the decision maker is, I'm giving you all this money, said, hey, test this marketing campaign at 1 or 2 locations in Detroit first, get some data, let's see if it's truly gonna work. Now, here's the deal. Remember this bell curve? In real business, you have what's called a null hypothesis and an alternative hypothesis. This is called hypothesis testing. And the null hypothesis is always what you're trying to disprove. The alternative hypothesis is what you were trying to prove. But here's the deal. In a bell curve in the real world, the null hypothesis gets all of this area under the bell curve. That if the results from your statistics ends up being in this middle part, this huge area, the null wins. You didn't prove anything. Yeah, you changed the numbers, but you didn't prove it. You didn't prove it was your marketing campaign that did it. It could have been randomness. If your statistic results ends up being way out here in the tail, you now have proven that something happened, that it wasn't randomness, that something caused that to happen. It's that proof then that gets you the multi-million dollars to do your campaign, because you're able to prove that it had a true effect. So in this case, this person says, we're gonna get all kinds of demographics. We want to see what different age groups drink iced coffee. We want to see if it's men. We want to see if it's women. We want to see the average amount of money they're spending on iced coffee. So all of this data is in the cash register. It's on the system. It's in the hard drive. They went back a whole year's worth and looked at every day how much iced coffee was spent, how many people bought it, what the demographics were of the person that somehow they were able to collect, let's say. They get all this information and they found 3 areas. Oh, I'm sorry, hang on, I went too fast. They get all this information and they now start the campaign, this marketing campaign. Half off iced coffee, half off from what time to what time? 3 to 5 p.m. And they do it for maybe a whole week. Detroit's getting swamped with commercials. Half off from 3 to 5 at any Starbucks for a limited time. And then the campaign ends. This is how it works. You gotta wait, there's a waiting period. In this case, it was a month. They waited a month to see what the residual results are from the campaign. The campaign, almost all campaigns have an effect right away, but do they have a lasting effect? That's what you truly gotta measure. That's what companies spend money for, is a lasting effect from a marketing campaign. Not just that initial effect, the lasting effect. So they waited a month. And after that month, they collected all the same statistics from a random sample that happened to have bought coffee recently. And the random sample, how many did they get? Let me see here. I don't know yet. Let's look. 50. So the person who's trying to get this budget and gets a random sample of 50 after the campaign's been over a month and compares all the statistics. And 3 of them showed an increase. You ready? Customers spent, am I on slide 1 or 2? I'm on 1. Customers spent an average of $14.18 with a standard deviation of 84 cents on iced coffee before the campaign. After, $4.26. It went up, $4.18 to $4.26. Don't celebrate yet, because for you to get the budget, the increase has to have statistically be up there to show that your campaign's what caused it. That's what's hard about this. Yes, you have an increase, but was it significant? Is it enough of an increase that your campaign truly caused it, without a doubt? Next, go back to 1. 43% of iced coffee customers were women before the campaign, and this is one of the statistics that went up. After, 46% of the sample was women. That's a 3% increase. So right now we found 2 statistics that went up, and here's the third one. Teenage females were at 21% that bought iced coffee before we did this marketing, 34 after. So here are the 3 null hypotheses. You ready? You're putting this together. You're the director of marketing. You've seen this used by your supervisor before you became the director, so you know how this is being used. And you're going, okay, the marketing campaign did not increase the average amount spent on iced coffee. That's what you're trying to disprove. This is saying your marketing campaign had nothing to do with an increase in the amount of people are spending on coffee. This null hypothesis, the marketing campaign did not increase the percent of women buying iced coffee. That's what you're trying to disprove. Now, there was about 7 or 8 null hypotheses, but these are the only 3 that the stats showed an increase. So these are the 3 you're writing about in your report when you're asking for this money. The null hypothesis is that the marketing campaign did not increase the percent of teenage females to increase the percent of those buying iced coffee. Those are the three items that increase. The null is. The alternative hypothesis that you're trying to prove is the marketing campaign did increase the average amount spent. Excuse me. The marketing campaign did increase the percent of women buying coffee. The marketing campaign did increase the percent of teenage females. That's your proof. And I tell you what, if you walked into this to the president of the company or whoever has to, or the executive committee who has to decide to approve this multi-million dollars for you guys to spend on this marketing campaign, you probably are going to have to prove all three of these, or at least two out of the three, for them to say. And here's one of the most important ones right here, because any company wants a return on investment for marketing. They want to make the money back they spent plus some. So that average amount has to be a significant increase that proves statistically that it was the marketing campaign or something caused it other than randomness. That's probably going to be the most important one, the one that they're eyeing. Increase in women is semi-important, but I want to also mention the increase in teenage females is important. If we had an increase in teenage men, that would be important also. The reason why this one's important, a company loves to introduce their product to a younger generation because their philosophy is if they like it, they're going to keep buying it. And now we have a new customer for life. That's the philosophy, to try to attract the younger. So this one's also important. These two right here, this is a significant new customer that's going to spend, if they keep coming back a month after the campaign, that means they're going to be spending money probably the rest of their life on something they probably didn't spend money on before the campaign. And this one, the average amount spent. All right, so here we go. How do we prove this? Let me review this. Matter of fact, I didn't put it on the board. Before and after. Here's before. Here's after the campaign. 318, and after the average spent, I'm sorry, not 318, 418. 418, before the campaign, after the campaign, 426. 426. Before the campaign, 43% of women, adult women, and 46% after. And then teenage females, 21% before, and I think it's 34 after, 34 after. Okay, now here's the weird part about research. You have to decide, the human involved, the humans have to decide what's going to be the basis to decide whether this was significant or not. What are we going to use? When we calculate this and we turn it into a probability, what does that probability have to be down to? What's the lowest we're going to go? What's the most we're willing to accept to say yes? We can reject that null hypothesis and we can say the marketing campaign had an effect on this particular item. What is that percentage? And a lot of companies will say 10%. Some companies will say 5%. It's all a matter of how important it is that, or whatever this research is, or whatever it is you're measuring. So, if there's several $1 million involved, and that's what you're asking for, a lot of people are going to say that's pretty important. So they're probably going to use either 10 or 5%. So since this is all about one direction, the marketing did not increase. The word increase is telling you which direction. The alternative is that it did increase. If the amount being spent, what we expected was 418, and it came out at 426, when we do our calculations, 426 needs to be somewhere in here, either at 10%, which is 0.10, or 0.05, which is 5%, are the most common measurements used in business and research to determine if the item you're measuring had a result or not. If you're above 10%, then you didn't really prove your marketing campaign did it. It could have been randomness from the sample that caused it. There's all kinds of things that could have caused it. But if it's way up here, then your marketing campaign's probably had an impact, a significant impact to get it way up there. So that's what we're trying to figure out. Say to yourself right now, try to take guesses. Is going from 418 to 426 enough to say my marketing campaign did it? Going from 43% to 46%, is that enough to say my marketing campaign did it? going from 21 to 34. Is that enough to say my marketing campaign made that happen? That's what you gotta say to yourself. That's where statistics is used in business, to prove whether it truly worked or not. Did your marketing campaign make that happen? All right, we just handed back homework where you used the mean already, so you know what this is all about. This is 426 or more. So 426 minus 418 divided by the standard deviation, which was given to us as 84 cents, right? Divided by the square root of how many is in our sample, which are 50. And as a matter of fact, it's all calculated right here. This was last week's. We're gonna focus on the proportions, but let's look at last week's just a glance and see what it turned out to be. Hang on, it's right. Nope, hang on, that's the pizza. Here it is. $4.26 or more minus 418 divided by 0.84 over the square root of 50. We get a Z of, where's the Z? Is that the Z? 0.67. Now, if we were using a Z chart, but we're not, we're gonna use norm S distribution. If we were using norm S distribution, help me, we got a Z of 0.67, help me write this out. Equals, what would I do? Not all at once, because I knew I was gonna stump you. Don't forget, ready? This is asking if $4.26 or more, $4.26 or more, what's the probability of that happening? So this would be 1 minus norm S dist parentheses 0. What's our Z? 67. And this equals 0.25, 0.2514. 0.2514. Is it below our 10% threshold? It's not. Because it calculated out to what, 25%? We did not prove that our marketing campaign made the average amount of coffee being spent go up. It could have been just randomness that made it happen because we're only taking a random sample of 50. So we can't go in there and say, look, my marketing campaign made this happen. I mean, you could argue it did go up, but it's a weak argument that it was your marketing campaign that made it happen. It could have just been the kind of week that made it go up. Go ahead.
What does 25% stand for, like?
As 25% chance that randomness caused this to happen instead of something else other than. That there was a 25% of just because our sample was only 50 out of a big population, that's a different number.
So the lower that number is, the higher odds that it was our
Something else other than randomness caused it. The lower this number, the lower that 25%, the lower that goes, the more proof you have that something else caused it other than randomness. I want to make sure you understand in the real world, if we were talking about a pharmaceutical drug or anything that humans ingest, they cannot get approval to sell that in the United States unless this is showing like less than 1%, 0.005. It's got to be in the tail, way there, 0.005, a half of 1%, that this thing that's about to be ingested by humans in our country has this positive effect, or you're not selling it. That's how our government's trying to protect us, by using statistics. Not one company can start selling pharmaceuticals in our country unless they have proof, independent proof, that then gets proven again that it's way up here that's causing this positive effect that's going on, and not just randomness from our one group to the other group. Drugs have a one group that think they're taking the drug and one group that's not taking it. And that difference in what the effects of that drug is has to be so significantly different that it's beyond obvious that the drug is having that positive effect to get approval. But in business, we're just trying to get a couple $1 million. We just want to prove that our marketing campaign is having an effect. So it's more like 10% or 5%. You don't have to go all the way down to a 0.5%. In medicine, I remember reading a physical therapy report where they were doing a study about the difference that's happening to patients who go through physical therapy because of some injury compared to those that didn't go through physical therapy. For them to prove that this thing that the therapy that these patients are going through ended up having such better results, they used 1%. And it was just, that's how the medical field is. They're like, we're gonna make sure our study proves that this medical technique is truly working. not just so there's no doubt about it. But in business, 10%, 5%. But 25%, you're gonna lose the argument. Randomness could have caused, there's 75% that something caused it to go up, but it could have been this, it could have been that. It's no definitely your marketing campaign. Yes, your marketing campaign could have had some of the effect, but it's not definite. Let's look at, now we're in proportion. Now we're caught up to today's homework. That's gonna be due by Saturday, right? Due by Saturday? No, after vacation? Okay, just making sure. Okay, after vacation. So now we're in proportion. So let's look at the next one. Whoops, let's go to the raw data. I don't want you to see that. I want to do it ourselves. 43%, but it went up to 46%. Did the percent of adult women who drink coffee, is that significant enough to say our campaign caused that to happen? So here we go. What proportion are we being asked about? 46% or more. What's the expected proportion before that campaign took place? 43%, or 0.43, 0.46. My question for you is, this expected proportion and that expected proportion, is that the 0.46 or the 0.43 in the denominator? 0.43, very good. 0.43, 0.43, and my sample size was how many? 50 it is. And we would calculate this all out and get our Z. Once we have our Z, let me get rid of this one now. Once we have our Z, we would plug it into our norm S distribution equation, find out the answer, and then we would do this. Let's do this norm distribution. Proportion being asked about, 0.46, comma. Expected proportion, 0.43, comma. Standard error. You ready? I like to do the longhand standard error because I want an exact answer. I don't want to calculate this myself and round it. So I'm doing the whole thing. Here it goes. 0.43 asterisk for multiplying, parenthesis, oh, I'm sorry. God, start over. Almost forgot. SQRT, parenthesis, 0.43, right? 43, yes. Asterisk, parenthesis, 1 minus 0.43, parenthesis, divided by 50, parenthesis, comma, 1. Everybody get that? Was that too much? All I did is I duplicated the standard error formula. SQRT, square root, parenthesis, the expected proportion, 43%, times, you gotta have the asterisk, it won't work, parenthesis, 1 minus 0.43, parenthesis, divided by 50, and then the ending parenthesis, so the square root has its ending parenthesis. Let's see what the answer is. Slide 31. Here it is. 0.46 minus 0.43 divided by the square root of 0.43 times 1 minus 0.43 over 50. We got a Z of 0.43. What a coincidence. The Z turned out to be 0.43 and our expected proportion is 0.43, but it's purely a coincidence. Help me write this. We're trying to find the probability that our research got 46% or more when we expected 43%, equals 1 minus or no 1 minus? 1 minus, because it's or more. NORMSDIST, parenthesis. Now, hang on. I'm going to put the dots in. I'm putting the dots in this time. A dot on the left and a dot on the right of the S. So now I got to do Z, comma 1. You got to put that extra number in if you're going to use the dots. So my Z is 0.43, I think. Yeah, 0.43, comma 1, because I used the dots this time. I put that in there. I get. Here's the answer. 0.3336. 0.336. Let's see, 33%. We're going up about somewhere in there, right in there maybe. I think that's about 33% or somewhere in there. My question for you is, do we have evidence that our marketing campaign caused the increase in adult women buying iced coffee? Yes, no, yes, no, no. Yeah, we didn't hit the 10%. We didn't hit the 5%. We didn't hit the 10%. We're at 20. What is it again? 33.36. 33%. There's no way we proved that our campaign caused an increase in women. So 2 out of 3, we do not have the proof. So all we have left now are teenage females. And that went from 21 to 34. Let me erase this. Let's put the numbers up here. Tell me what's on the left. Tell me what's on the right. What percent's on the left? This is now teenage females. Went from 21% to 34%. Which one's on the left? The proportion being asked about. What percent or more? The one being asked about is what it went up to. What's the probability? It went up to 34%, so 0.34. The expected proportion was 21%, so 0.21, 0.21, 0.21, and the sample size, the same sample, 50. There it is. Let me get this out. Once we know our Z, this is asking us, what's the probability of getting 34% or more when it used to be at 21% before the campaign? Equals 1 minus, I'm not putting the dots in this time, so all I need is Z. So I'm just waiting for that number right there when we calculate it. Now let's go with this right here. Let's do this one. You ready? Equals norm distribution, the proportion being asked about. By the way, when I looked at that homework, I was shocked at how many mistakes there were. So please make sure and use the correct answers posted. There are way too many errors on the homework. And what I fear is you're going to make the same errors on this one, but because there's only 5 problems, this is for sure detailed graded. So make sure and look at what errors you made on that previous assignment so you don't make the same ones on this one. 0.34 is what's being asked about, comma. The expected proportion is 0.21, comma. The standard error is going to be, here we go, S, Q, R, T, parentheses, 0.21, asterisk, parentheses, 1 minus 0.21, parentheses, divided by 50, parentheses, comma, 1. That whole standard error of the proportion, right there. SQRT, the asterisk, divided by 50, the parentheses around the whole thing, so it's all square rooted. We do all that. Here's what we get. Again, it's all calculated right here. 34, let's see if I can make this bigger. 34% minus 21% divided by the square root of 21% times 1 minus 20% divided by 50 equals a Z of 2.26. Look at that Z. Here we go. 2.26. 1 minus norm S distribution, 2.26. This ends up equaling, are you ready? Equals 0.0119, thank you, 19. Look at that. Look at that. That came out to 1%. Just over 1%. That's right there. We're right there in the tail. We're in the magic area. We're in the end zone. We have proof that our marketing campaign increased the percent of teenage females buying iced coffee. We got maybe some new customers for life. So it did have a success in some way. But you gotta remember, we were looking maybe at 10 different demographics to start with. And there were only 3 that showed an increase, and only 1 that showed what's called a significant increase that we were able to prove our marketing campaign is what caused it. So now the decision is, if you were on the executive committee and you had to make the decision, if you're about to have the company spend, let's say $3 million to take this campaign worldwide, would you risk the money on these results? Yes or no? No? Anyone? That's a matter of opinion. Some companies will say yes and some will say no. Some companies think that this is worth it. That one thing, that one item that proved that it went up from 21 to 34. But most companies, because this one didn't go up, the average amount spent significant enough, probably will say, no, let's try a different campaign. Now, or they may say, look, this campaign should have worked, maybe something happened. This is very common. Let's do it again in Dallas. They'll go to another big city and say, let's do it again. Let's just spend a couple 20, 30,000 like we did in Detroit, and let's do it for a couple locations and let's see what the results are again. And they'll say it's worth the risk because maybe there was something about the campaign they really thought would have worked, and maybe it was demographics or something. And that's how it happens in the real world. So all you marketing majors, if you end up at the big time, at big companies, you gotta realize how to get the money. How do you get the budget? By proving that your ideas of your campaign will work, by test marketing it. And this is how test marketing is done. And that's where true research, true statistics is being used in business. All right, I wanna show a couple more examples. So I'm gonna go to, so now you know about, by the way, I would say there's at least 2 or 3 weeks of your next business statistics class that's all about hypothesis testing. So matter of fact, I need to mention a few words again because you're gonna be, this is a big part of your next class. The null hypothesis is always what you're trying to disprove. The alternative hypothesis is what you're trying to prove. Now, you're gonna be asked to calculate all this, and you're gonna come up with this 0.0119, but then in 302, you gotta answer the question. Would you, and here's the 2 phrases, would you reject or not reject? You can't say accept, let me repeat those. Would you reject or not reject the null hypothesis? So are you ready? I want you to tell me whether you would reject or not reject. When you reject the null hypothesis, you're saying you have proof your alternative is good. When you don't reject the null, it means you don't have proof that your alternative was what happened. So here's the deal. Here's the null. The marketing campaign did not increase the average amount spent on iced coffee. Reject or not reject this based on the results we calculated. Come on. Reject or not reject this. If you reject this, that means your alternative is true, that the campaign did increase the average amount spent. If you do not reject this, it means you didn't have proof that your campaign caused the increase. Reject or not reject?
Not reject.
Not reject, thank you, Colin. He's the only one that wanted to participate at this moment. And I appreciate it because he never shows up. Yes, I'm not editing that out. The marketing campaign did not increase the percent of women buying coffee. Do I reject or not reject this null hypothesis? Can I reject it or not reject it? Did our campaign show proof that we increased the women buying coffee? If so, we reject it. But if our evidence didn't show that we have proof it increased the percent of women, we can't reject it then. Are we rejecting or not rejecting? Not rejecting. Thank you for speaking up. I appreciate it. Null hypothesis is that our marketing campaign did not increase the percent of teenage females buying iced coffee. Do we reject or not reject that null hypothesis? Reject, exactly. We reject it because we do have proof. That's the only thing we have proof of, that our marketing campaign did increase the percent, and so we can reject that null hypothesis. That's what you gotta learn about 302. That's the words, reject or not reject a null hypothesis, and you give this information as evidence to your answer, whether reject or not reject. Researchers always go into it wanting to reject that null hypothesis, but they have to statistically prove. They gotta be way up here or way down here to prove they can reject that null hypothesis. Now, I wanna make sure you understand how research works, because I'm a teaching professor, I'm here to teach, but then we have a lot of professors that are doing research here, getting paid, getting funding from the government and companies to do research. And they're doing exactly what I'm describing here, trying to reject the null hypothesis. The point I wanted to make is, before a professor can get their research published in a national, professional, whatever it's called, a publication, they have to submit it, and then the publication has another team to try to duplicate it. The process, they duplicate the way randomness was done, they duplicate where the sample is being taken out of, the same population, they're applying the same statistics to see if they get the same results. Before any research gets published, they have to go through that kind of process, where other people are looking at it and trying to duplicate it to prove your research is real or not. So when you start hearing on the news, hey, this research said this, research says that, you can have confidence that hey, somebody proved not only that is it way off the chart here, that something's affecting something, but that someone else even duplicated their research to prove that they were right. Before you hear it on the news, that happened. That's how research works. All right, let's go through a couple examples, get ready for the homework. So I put these together. Are they here? What's this? Yeah, right here. Here's one. Help me out. I'm just wanting you to help me fill in the numbers here. Let me get this out. Let me get this out. Hang on. Right here. Help me do this. Help me do this. Let's get all this done like it's a homework problem. We don't need the before and after. We don't know our sample size. Here we go. At a particular college, 71% of all students are receiving some kind of financial aid. I want to tell you, I would never have made it through college without financial aid. I mean, I literally had to take out loans just to survive. At a particular college, 71% of all students are receiving some kind of financial aid. The school newspaper selects a random sample of 100 students, and 69% of the respondents say they received some sort of financial aid. What's the probability of getting 69% or less from that sample? 69% or less from that sample. Okay, what is the proportion being asked about?
69.
That's right, 0.69. What is the expected proportion?
71.
71, 0.71. 0.69 or 71 goes here on the denominator.
71.
That's right, the expected one, 71, 0.71. Sample size? 100. You got it. All right, I'm gonna go, this, you know, it's gonna be, is this gonna be a norm S distribution or a 1 minus norm S distribution for this problem? Norm S, because it doesn't say 69% or more, it says 69% or less. So you know it's just norm S without the 1 minus. Let's go to this one. Is this one a 1 minus or not a 1 minus?
No.
Not a 1 minus because it doesn't say more, it says less. The first number is gonna be 0.69, comma. The second number, 0.71. Does anybody feel confident enough to talk me through writing the Excel equation for the standard error of the proportion? Please, hit me. Look at me. That's right, SQRT, parentheses. Thank you.
0.71
Perfect, 0.71.
times.
What's that?
asterisk,
Ah, look at that. Man, she's all over it. Then what?
parentheses,
Very good.
1 minus
1 minus.
0.71
Perfect.
parentheses,
Parentheses.
divided by 100
100.
parentheses,
Parentheses.
comma 1.
Comma 1. Very good. Wow. If I could give extra credit, I can't.
Participation points.
But if I could,
Participation points.
I wish I could.
Oh.
Yeah, I can, that's right. You spoke up, you participated, you're right. You just increased that percentage of where I gotta go and try to remember everybody at the end of the semester. Very good. All right. It did count. Perfect, by the way. Whoops, let me just put this in front. There. All right, let's do, we got another one. These are becoming too easy, aren't they? 20% of Woodrow students believe Wednesday will be a windy day. You take a sample of 50 students and find that 15 of them believe Wednesday will be a windy day. What's the probability that out of a sample of 50 found 15 to believe Wednesday's a windy day? Wait a minute. Found 15 or less or 15 or more? Oh, this is a poorly written problem. Oh, let's change it right now. 15 or more. You want to do 15 or more or less? We got to do more, right? Or more. There we go. Save. Boom. Now here's the deal. This is just like one of your problems in the homework that doesn't give you the proportion being asked about. Right? So we have to find our proportion being asked about. Hang on, let me get my calculator. How am I going to find that proportion? What am I going to do? Go ahead. Wait, Grace, you should know this. We talked about this, didn't we? No? Isabel? Did we talk about this?
Yeah.
We did. Tell me what I should do to find that proportion.
You do 15 divided by 50.
Perfect. 15 divided by 50. 15 divided by 50. The story kind of gives you the proportion a little bit. So I'm going to take 15. Whoa, come on. Wait, come on. I'm going to use touchscreen. It's a lot easier. 15 divided by 50 equals. So this is going to be 30%. So now we have all the information. The question being asked about, we just calculated, and it's 30%, 0.30. The expected proportion that goes here, here, and here is what was given to us, 0.28, 0.28, 0.28, and the sample size is, I can't find it, 50. There it is, not bad. The only trick to this one is you had to realize to take that 15 divided by 50. Now, I want to go to my norm distribution equation right now. Do this real quick. How do I start this one though? 1 minus. Because this is, we're asking about 30% or more. 15 or more out of 50. 15 or more out of the 50, which means 30% or more. So norm dot DIST with the 1 minus in front, everything else is the same from there. 0.30, comma, 0.28, comma, SQRT, parenthesis, 0.28, asterisk, parenthesis, 1 minus 0.28, parenthesis, divided by 50, parenthesis, comma, 1, parenthesis. Wow, that's hard to remember. I figure if Nermi can do it, I can do it. 1 minus was the most important part to put in front. Everything was the same once you got knew to realize to take 15 divided by 50, everything was the same like any other part. I posted these, but I didn't post the answers, so hopefully you took notes and you want to print this out off a canvas, you can just write your answers on it. All right, now here's the big one. You gotta go to number 23. Here we go. 23B. 23 says a random sample, I'm right here where 23 is, a random sample of size 200 is taken from a population with a population proportion equal to 0.75. We're doing B. What is the probability that the sample proportions between 70 and 80? 70% and 80, 0.70 and 0.80. This is an exam question. This is between two proportions. This is, you should have seen this coming. This is just like your number 5 on your homework. And it's just like number 7 and 8 was on last week's homework, but it's proportions. That you're doing between two numbers. And I said to you last week on that homework, make sure and treat each number individually to make this easy for you. I noticed some of you on the homework took a norm mass distribution equation for one, like the 0.70, and then norm mass distribution equation for the 0.80, and made it all one long norm mass distribution equation, one minus the other. That's fine. That works perfect. I'm happy with that. But I also said you could do one at a time and get a result, do the other one, get the results, and then subtract the two results. As long as you get a positive result, take the big one minus the smaller one. Go ahead. Oh, okay. You can do it that way. But on the norm distribution, the part B's of all of these, especially this one that's going to be between two proportions, I'm requesting that you do it as one long norm distribution equation, which are two equations, one minus the other. One long one. That's all I'm asking there. Because some of you did do two equations and then got the results and subtracted them. But I'm asking you to do one long equation. On detailed grading this time. Come on in. We don't mind. There's a scavenger hunt going on. Someone from this class know about that? No one knows about it? That scavenger hunt? What? I don't know what class it is, but someone put me on there, so they gotta find me and take a selfie. So I thought maybe that's what that was. They probably didn't want to come in the middle of class. I thought it was somebody from here that gave it my name. I can remember someone asked me about it, but I said, look, I'm not on campus enough. And they said, that's perfect. They'll never find you. So that's the objective. Where am I? Oh yeah, between two proportions. Here we go. Let me give the eraser so we can do this problem. We would have to do this twice. Hang on. The denominator is not changing for either one of these two equations between 70 and 80% because the expected proportion is 75%. So I can put 0.75 here, 0.75 there, 0.75 there, and the sample size stays the same, which is 200. So there it is, the standard error remains the same. 0.075 remains the right-hand side, but we are doing this twice, once for 0.70 and then again for 0.80. So once this way, a second time that way. And we're gonna get two z's, which we will then put into our norm S distribution equation. But here's what I want. I want to do this equation, because I want to make sure you see how to do it in one long equation. Not, because a lot of you did it in two separate ones, and we got to get to the point to where we can do this in one. So I'm going to do 70 and 80 together, like part B, all in one equation. I'm assuming, I got to look at it here, that the 80 would be a bigger probability. So I'm going to start with the 80 and finish with the 70. But if I got it backwards, I just move the first two numbers of the two equations is all I gotta do. If I end up with a negative result, just move the first two numbers and I got a positive result. Here we go. Equals NORMDIST, parentheses. I'm doing the 80 first, 0.80, comma, the expected proportion is 0.75, comma, now here's the standard error. SQRT, parentheses, 0.75, asterisk, parentheses, 1 minus 0.75, parentheses, divided by 200, parentheses, comma, 1, parentheses, there's one of them, minus, no equal sign, minus NORMDIST, that's an N, that's a sloppy N, parentheses, but now I'm not doing 80, I'm doing the 70 now. 0.70, comma, 0.75, comma, blah, 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 parentheses. Everything else is the same as it was right here. SQRT, 0.75, asterisk, 1 minus, blah, blah, blah. It's just the only difference is this one has a 0.70 in front, this one has the 0.80, and I'm subtracting the two. And if I got a negative result, I'd take that 0.70, bring it up here, and take that 0.80 and switch it to there. That's all you gotta do if you get a negative result. You just have them backwards. This class is too easy. We are almost done. Can you believe it? After this, we have quality control next, the week after Thanksgiving, and then some BS on December 5th, whatever the heck that's gonna be, who knows? And then that's it, we're done. So we only have, this is done, so we only have 3 more lectures. That's it, 3 more times, and we end this relationship. We get a divorce. That's it, 3 more. Ready for your in-class? Wait.